Hey everybody, I've got a new proof of concept to show you. Been working on this for a while, and if you've been to my website you may recognize what this is behind me. If not, well then I'm going to show you a short animated video of what this concept is, and then I'll show you the different pieces on the machine behind me. Well, there we go. That was a pretty good little video animation. Took me a long time to do that one, and I did it several years ago. And you see there was three parts. There's the lifter, there's the gravity bank, and there's the carousel, and then there's the gearbox. And so with those assemblies all together, you have a pretty good method of storing items into the gravity bank. The lifter itself is the one that I used previously, and in one of my previous videos I had introduced a Otis elevator safety brake, and so that's still in place, and it's not quite as important whenever there was 500 to 600 pounds in the lifter, but this allows me to release the lifter carriage pretty easy, so that whenever I want to reload the gravity bank, it's easy to manage the lifter. So once the lifter's down into its lower position, then I can easily load in another battery. And then that battery is ready to be tilted up and put into the gravity bank. There we go. This is a counterweight. So the counterweight serves two purposes. One, it keeps me from having to tilt up the weight of the carriage whenever I'm loading up the gravity bank. That would be an added amount of weight that I'd have to tilt up every time I tried to tilt up a battery. So it serves that purpose, and then it also serves the purpose of allowing me to lower this lifter carriage without having to worry about the weight of the carriage slamming down and me holding it so that it won't hit the bottom too hard. you can see with two people operating this, it wouldn't take very long at all to load up this gravity bank. If you had a larger area and a greater distance to extend your gravity bank out, then you could double, triple, quadruple the size of your gravity bank and never have to change the size of your lifter, or for that matter, the back end, the size of your extraction process. So it makes it a lot more versatile. This is a sample of a battery. I made these little rollers that will fit on that supporting pipe. I printed these out with my 3D printer, and I had a bunch of roller blade bearings, and they fit nicely on either side of the rollers, and they all work fairly well. Some of them have split. You can see on this one it's got a little split there, but that's just a product, I guess, of the 3D printer. But a little bit of glue will glue that back together. Sometimes it splits more towards the center of the roller. I guess that's where the most pressure is when it's rolling. So I've had a few of those break, but it's real easy to fix. And then of course the battery itself is, they're 33-pound blocks, cinder blocks, and I've used duct tape and a wrapping strap to put around on it, and I cut some pieces of metal and screwed some cement screws in there with a little bit of Gorilla Glue, and so far I haven't had any of them break apart, nor have I had any straps come off, so that's good. Of course, this is the gravity bank, and the most important piece is right up here, and that's the front gate and the back gate that is operated as the carousel turns. Those front gates and back gates open and close, allowing these blocks to slide off on into the carousel. You can see those two gates are spring loaded, and they're both in a normally closed position. The front gate is already being activated by this bolt that's on this main drive shaft pulley, and this bolt here is already starting to engage. This wheel comes around, and it's the normal rotation of this wheel, which is part of the main drive shaft up at the off this sprocket up here. It will pull this and raise this front gate at exactly the right time needed for it to drop it off onto this little porch. And down here is coming off of its porch as it lands on this lower discharge ramp, and when it does, it'll come off of the carousel, but that final bit of energy that's left in that battery will help drive the release mechanism for this battery. So let me show you the only thing that's keeping this from turning right now. I have a slight slippage on my belts. The other day I came in here thinking I had turned this completely off, and lo and behold, my blocks had all wound up down here in the discharge ramp. So one of these, that large wheel back there, has a slippage on it that will eventually allow the blocks to come on down. So you can see this is slowly getting closer to the bottom. The lights are on up here. We'll see if we can catch it when it goes sliding off, and hopefully not every battery is made identical. I wish they were. Most of them work exactly as described. Some of them are a little higher, a little lower. Sometimes my gate doesn't always open as much as it should, so we'll see if we can catch it here. It's real close. Whoa, there it went. And that one disappeared, went into the discharge state. And now this one is a little tilted, but it's still working. Oh, it stopped. There it goes. It's running again. The reason I had to tilt this carousel at an angle is because I couldn't get this to be any higher. If I had about a foot or maybe a foot and a half in height, then I would be able to raise the upper ramp so that I could tilt the carousel back up closer to a 90-degree angle, which would make it which would give me the ability then to drop these weights down into sort of a chute. The gearbox itself is pretty simple. Since I'm not having to offload the entire weight of my gravity bank or what's contained in the lifter, which is normally just a single standalone lifter, in the past has had around 400 to 600 pounds in it, so I had to compensate for that with a number of different stages to extract the energy from something that large. With the carousel and the gravity bank, I can siphon off a portion of the load that I've lifted up into my gravity bank and siphon it off, in this case about 70 pounds for each drop, or each drop from the gravity bank. If I wanted it to be 2 blocks instead of one block, the only thing I would have to do is to put another set of bolts at 180 degrees across from this bolt, and that way whenever I had a support come by, or a porch support come by, I would have an offload from the gravity bank into each one of these slots. These slots are about 18 inches apart. They're half of a circumference of this large sprocket. That way for every turn of the sprocket I could offload a set of 2 blocks and have about 140 pounds in the carousel. As it is, this takes care of all of the drops that I need to make in order to get this large generator, this large blue generator, working. or the smaller generator that I have back here in the back. This generator came out of the gravity light, and this gearbox came out of the gravity light. It doesn't take much to produce an output. You can see just barely turning this produces an output. So this big generator gives me about, unfortunately, only about 7 minutes per block runtime. The small generator gives me 20 minutes. So that's about right from previous tests that I've run. Well, there we go. That was a grand finale, I think. I wanted to throw that in there to show you that I can get a few of these blocks to run without assistance, and sure enough, a few of them did go through. I'd like to show you all of them going through without any kind of a problem, but that doesn't usually happen with my experiments, so something this time did happen. You saw a quick loss of support whenever that chain, major drive chain, came off of this lower sprocket. And whenever it did, of course, the battery discharged just as fast as gravity would let it discharge. And so I got the chain put back on. I've had that happen a couple of times. It's my own fault for pushing on the block whenever it's going down and not making sure that I didn't push the chain off a little bit and skew it, because One thing's for sure with chains, you need to be sure that the sprockets are parallel to each other. It's not quite as bad with a belt. You wind up with a worn belt, but with a sprocket, something like this can happen. And I was pretty lucky. The only thing that, the only damage that was done is I lost one of my little supports. So we'll weld that back on and get started again with the next, with whatever's next. I really enjoyed doing this video, and hopefully I'll be able to supply some more info to you later and some more demonstrations on the usage of a lifter. And in the meantime, be safe and build more lifters. Thanks a lot.